I'm Anil Kumar, and here is a question from the test paper. It's on application of cosine law. We can actually find distances in universe using cosine law. The question here is, two different positions of Venus is given in the diagram below. Assume circular orbits for Earth and Venus to find the distance between the planets and the Sun. So we have assumed that Earth and Venus are moving around Sun in circular orbits, right? That's a very close approximation. Now we have two different positions of Earth and Venus. In one observation, the angle between from the Earth, when you measure the angle from the Earth to Venus and Sun, it is 31.8 degrees, and the distance from Earth to Venus is 5.53.1 million kilometers. So that distance, E to V, I should say, is equals to 53.1 million kilometers, right? So that is the distance, and the angle in this particular case, let me write this at angle at E. Let me write this as angle at angle 1, right? So angle 1 in position 1 is 31.8 degrees. In position 2, the distance from Earth to Venus is 210.2 million kilometers. So the distances are in million kilometers. Let me write million kilometers here, and the angle measurement is 29.3 in degrees. So you are given these two positions. From here you need to find distance between the planets and the Sun. That is, let us say distance between Earth and Sun is A, and distance between Venus and Sun is B. You need to find A and B. That is the question for you, right? So distance will remain same since both are circular orbits as assumed by us, right? So that's an approximation. With this approximation, we'll find distance from Earth to Sun and distance of Venus from Sun, correct? So you can pause the video, try it out, and then look into my suggestions. So we'll apply the cosine law. Now, from the cosine law, we can say that Venus to Sun, that is B, we'll write equation in terms of B. So we can say B square is equal to this distance. B square is equal to 53.1 square plus A square minus 2 times these two product times cosine of the angle in between. That is cosine law. So I'm straight away writing the values here, right? So it is 53.1 square plus A square minus 2 times 53.1 times A times cosine of angle, which is 31.8 degrees. Correct. Now you can actually use the calculator to find the values in this case, and then simplify it a bit. From the second position, so these are two different positions. Let me write them as let us say position 1, and this one is position 2. So this is in position 1 and in position 2. Using cosine law, we get B square rather, as equal to 210.2 square plus A square minus 2 times 210.2 times A times cosine of angle, which is 29.3 degrees. Right. So we have two different equations with just two variables. So you can always solve for both the variables. That will give you the distance between the two planets, right? So that is how you can actually get to the answer. Now, easy way to solve is if I do A minus B, right? So in that case, B square minus B square is going to be 0, right? So let us do A minus B. That is, what I will do is let's call this equation as equation 2, and this is, let's say this is equation 1, this is 2. So now let's do equation 2 minus 1. So if I do equation 2 minus 1, then b square minus b square is 0, right? Equals to, we can use the calculator to write down the answers directly. So we have 210.2 square minus 53.1 square equals to, that gives me 41364.4, right? Now a square minus a square is 0, and now we will have this term with a as a coefficient, right? So I'll do 2 times 210.2 times cosine of 29.3, right? So this is equal to 366.61, and from this term I'll take away that term. So I'll do minus of 2 times 53.1 times cosine 31.8, right? So the answer is 276.35. So it is 276. Let me say 36 and a, correct? And a. Perfect. Now from here we can find the value of a. So we have a as equals to, when you take it on this side and then divide, you get 41364.4 divided by 276.36, and all this is in million kilometers, right? So now we'll divide 41364.4 by 276.36. That gives us 149.6, right? So it is 149.6 million year, right? So into 10 raised to power 6, right? Kilometers. Million is 10 raised to power 6 kilometers, right? That is what it is, which you can actually approximate, right? So we can say this is approximately equal to, we can write this as 1.5 into 10 raised to power, so we move 2 places, 8 kilometers, right? So we could write this distance a, that is from Earth to Sun, the distance should be 1.5 into 10 raised to power 8 kilometers, right? Now once you know that distance, then you can find distance from Venus to Sun. Use any one of these formulas. So let me use the first one, which is b square. So I'll say b equals to, we'll use square root 53.1 square plus, instead of a, I'll write all this number, right? So I'll just write 149.6. We know it's million, everything is in million. So I'll write 149.6 square minus 2 times 53.1 times 149.6 times cos of 31.8, right? So that gives us the distance of Venus from Sun, right? So we'll again use the calculator. Say square root of 53.1 square plus 149.6 square minus 2 times 53.1 times 149.6 times cos of 31.8, right? Bracket close, equal to. So that gives us 108.15 million kilometers, right? So that is what it is. So we can again approximate this as equal to 1.1 into 10 raised to power 8 kilometers, right? Million means 6, and then we are moving 2 decimal here, writing it in the scientific way, 1.1 into 10 raised to power 8 kilometers, right? So that is how you can use trigonometry, and especially cosine law, to find these large distances. I hope you understand and appreciate the solution. It's a very important question from test point of view. So many students get this question, and I hope it will help you get better marks. Thank you and all the best.